Hey guys, and welcome back. So I decided to kick off this series with something relatively simple. And as you can see by the title, it's how to find your script's parent process. So what do I mean by that? Well, as you may know, you can run your script directly from your terminal, meaning from a bash session, in which case bash would be its parent. But you can also run your script within some other scripts. And in those cases, the scripts calling your script would be its parent. So that's exactly the situation I ran into a few days ago. Basically, I have one script that is being used with two different scripts, and based on the script that is calling that underlying one, it should actually generate a slightly different output. So let me actually demonstrate so you can better visualize what I'm talking about. So it's basically uh, the two Rofi menus I have for wallpaper selection. So the first one, the older one, is basically just a list of wallpaper files, and it works pretty fine, nothing wrong with that. But I also have the other one that does exactly the same. The only difference is, as you can tell, this one is showing you wallpaper preview. So you don't have to memorize wallpaper by its file name, but you can simply see the image that you want to set. So as you can tell, both of them require a list of wallpapers in order to um, generate the content. So that behavior stays common between both of them, but the image preview menu requires a couple additional arguments. So one is for indicating a currently selected wallpaper. So for example, if I type the name of my current wallpaper, you can see the background around it is slightly darker, which indicates this is currently selected file. The same behavior is present here. So if I type wallpaper's name, you can see the darker background. The only difference is this is being achieved, so to speak, internally. So I don't need to pass any additional arguments in order to achieve this with this style of menu. So with this menu, that's not necessary. And also the other bit of information that I need with image preview is basically command that needs to be run upon wallpaper selection, because I'm using that Rofi menu for other use cases where I need to display images. So those use cases have a different purpose, meaning it will basically perform a different operation when you select an image. So um, for those of you who are already somewhat familiar with Bash, uh, I'm sure that you already saw an easy way to solve this issue, and it would basically be just passing a positional argument to indicate from which script the helper one is being called. And I will refer to the common script, the underlying script, as helper script, just so I have some kind of consistency, so I don't get you confused. So parent scripts are, well, I can actually call it child, so it will stay consistent with the analogy. So two scripts that are calling that underlying one, I will call them parents, and the underlying one would be called the child because well, I guess it will make more sense. So you can very easily pass an argument indicating from which parent the child script is being called, and within the child script we can simply say if the parent is X, generate this output. If the parent is Y, generate the other one. Or in my case, I would basically need to either provide additional arguments or just suppress it. So that would be, again, very easy way, and it would do the job. It would work perfectly fine, exactly the same this one is working. I was just thinking, well, what if I ran into a same situation, but I won't be able to actually control what is calling my script. I wouldn't be able to pass any kind of indication from within my parent process, meaning I wouldn't have any way to know uh, what process is calling my script. With that being said, let's jump into the code, and I will show you how to do it. And one disclaimer, so I know I promised that there won't be generic examples, but in this case, since the script in question is being called by Rofi menus, and Rofi is graphical tool, I think it would be very difficult to actually show you any kind of change in the output, because basically whatever the output of your script is, that would be rendered through the Rofi menu. So I think just for the sake of conveying my point better, I think it would be easier to actually use generic examples, and that will actually help you understand the whole concept much better. So, okay, let's jump into the code. Okay, I will make a new bash session. Let's actually full screen this window, and also let me increase the font so you can see it better. Okay, so first let's actually create parent scripts. So neovim, and both of them, like this for this demonstration, they will look exactly the same, because the only point, the only purpose of these files are to have different names. They will just call the child script. Real work would be exactly within our child script to actually find out which one of those two parents is calling it. So let's start with in bash, and as I said, the only thing the parents will do is basically call a child sh. I will save this. I will make it executable, so we can copy this and basically just paste, save, and make it executable as well. So that's basically all that needs to be done with parents. And now let's jump into and write our child. And we can basically do the same. Here we will actually write our child code. So for those of you that already have some experience with bash, you probably know that if you want to get your script's process ID, you can do that using $. So let me actually show you how that works. So let's call the variable PID, like process ID, and we can use $. And then we can simply say echo PID. We can save, make it executable. So for those of you that are new to bash, just to point out, when you want to get variables value, you will prefix a variable name, which is in our case PID, with the $. So when you are assigning value to a variable, you will just use its name like this, PID. And when you actually want to get what's in the variable, you will actually use the $sign. So I'm pretty sure that most of you watching the video already know that, but like just in case there is someone who is less experienced, I want to cover all grounds. Okay, so let's actually run this. So I can say child, and we get some kind of ID, but we are not sure what it is. So the tricky part is that if we try to use PS on this process ID, well, we won't get any running process because our script already finished running. So there is nothing running anymore with this process ID. So what we can do, we can actually make our script process run a bit longer. So we can say something like sleep and give it like, well, let's say 10 seconds. I think that would be enough. So when we call the script, and I have to use ampersand, that way the script will be called in the background, and I will get back the control over the terminal or over my current bash session. So it won't be waiting for the script to execute in order to let me um, continue using my bash, but it will actually put the current process in the background, and I will get control to try to PS the process ID that it will print. So let's try that. Okay, so if you say ps-p 1598683, so it actually tells us that that process ID belongs to our child.sh process. Okay, so how can we actually find the parent of our script? It's very simple, and we will use the same ps command, which for some of you might be obvious, because whenever you are dealing with processes, that's basically the command that will help you get more info. And throughout my other videos, I will use PS in different ways. So like this is not a comprehensive tutorial about PS. This is basically just about this single um, feature, basically just getting the parent process ID. So as we did previously, we can say PS P, and then we can say process ID. That way we would get more info about provided process ID, which in this case is our own process ID. So we would see the same output as before. So we run this, and since we used PS while our script was still running, we can see that that process ID belongs to our child.sh. So we can use the same. The only difference is that we want to provide the process ID of our parent. But the question is, how can we get a process ID of our parent? Well, the PS command has a very handy option to actually customize its output, and that's basically just -o for, I guess, output. And we can specify what exactly we want to get back from the PS. So what we are interested is basically PPID, or I guess parents process ID. And let's actually try that. So if we run this, now we can see that again we got just an ID number, but we don't know uh, which process that ID belongs to. We just see the ID value. So, okay, let's actually try to use that process ID in the Same way we use it with our scripts process ID to actually get more info. But obviously, here we actually get two lines. First one is header, which basically just holds a label for all the information that PS will output. In this case, we are outputting only single information. So yeah, we see one column in both rows, I guess. So in order to get only process ID, we can use something like tail, which will basically, um, for lack of a better term, just cut the output starting from the bottom. So head would do the same, but from opposite direction. So it will start from the top, and the tail will do that from the bottom. So we can say tail -1, meaning that we want to keep only the last line. So we want to start from the bottom and stop after the first line. So let's see how that looks. Then surely enough, we got our parents process ID. So let's actually save this somewhere because we want to pass it to a next command. So we can say ppid equals to this whole expression. And we want to use that ppid with ps the way we use it before with our scripts process ID. So hopefully this will actually show us our parent process name. And if we try to run it, we can see bash. And since we are running it from the bash session, that's no surprise. But we actually created our parent scripts just for the purpose that we can determine which one is calling our child script. So let's actually try that. If we say parent1, we can see parent1. If we say parent2, it says parent2. So that's actually great. That's actually what we wanted to get. But I don't want to say this code looks messy, but it can certainly um, be a bit cleaner. So let's actually keep this code, but I will try to refactor it in one-liner because I think for as simple of a use case as this one is, I think it's basically just more convenient. So we still want to use ps-p on our scripts process ID, and we still want to output its parent process ID, but instead of manually parsing the output, we can simply use equal sign, and PS will suppress the header column, and it will basically just print ID value without labels in the first row. So let's see how this part looks like. And we can put exit here, so the rest of the code doesn't execute. Script will basically stop execution right after this command. So if we do this, let's go back to the child, and we see that we got a process ID. Okay, so how can we use it without actually saving it into variable? Well, that's where xargs command comes really handy. And what xargs does is basically a very convenient way to turn your input into a arguments for a given command. So let me actually demonstrate that on a simpler example. So if we say something like echo e and then so 1, 2, 3, for example, we can see echo will print it in a different lines. But if we pipe this through xargs, it will simply use those three lines, but as argument to some provided command. So by default, xargs will use echo, and that means that echo will only print those three values in the same line, as you can see, which is exactly what happened. But we can use it with something like, let's say, touch, and that should actually create three different files. So to see if our files got created, we can use find on current directory, and just so we don't go further, I will say max tab equals to 1, and then I want type to be only files, and I want only files that were created in provided number of minutes. So in our case, let's say lesser than 5 minutes. So if we do this, we see that there is file 1, file 2, and file 3, and also our child.sh because yeah, it was created less than 5 minutes ago. So we would use xargs in a similar manner here with our process ID. As we know, this first part of the command will actually give us process ID, and then we want xargs to take that process ID and actually use it as an argument to another ps command. So we can say ps, then -o, and say args, and again we want to omit a header, and for the process ID that we want to get this information for, we will say -p, and our parent process ID that we got will actually be appended at the end of this command. So let's actually see how that looks. And we see we got the bash, and if we say parent, let's go with parent 1, we see parent 1. If we go with parent 2, we get parent 2. So if we want to go even a little bit further, we can actually use something like awk to print only the last part, which would be actual process name. So we can do something like print nf, and for those of you who are not as familiar with awk, NF stands, well, at least I think it stands for number of fields, fields being columns, and by default, if we don't specify any particular delimiter, awk would consider anything that is white space separated as a separate column. So in our case, we see that we get the bin bash and then parent 2, for example. So they are separated by white space, meaning awk would consider that to be two different columns. So a number of fields or the columns would be 2, and the $sign in front of that number. So okay, let me actually remove $sign, and we should basically from this whole output get only a number 2, because that's the number of the columns that awk would be able to count. So if we do this, surely enough we see 2, but 2 is not useful to us. But awk is giving us an option to basically print specific column based on its index. So if we put a $sign back there, we would say awk that we want it to print second column. So you may wondering why I simply didn't put 2 here like this. And it's because in this case there are 2 columns, but using NF, it guarantees to always print the last column, because NF will give us the number of columns, which always equates to the last column index. So this way, using print NF, this will actually always print the last column regardless of how many columns there are. Okay, so now we just need to, I guess, save this value, and I can call it like parent and save it like this. And what I can do here is perform a simple check and say if parent contains, for example, 1, we want to perform, let's say, echo E, and then, so let's say 1 and 2, or otherwise we want to print, let's say, 3 and 4. So let's actually remove this part of the script and try if it works. So let's call it on parent 1, and we see 1 and 2. And if we call it on parent 2, we get a different output. So again, as I said earlier, so this could easily be done using positional arguments, which in this case, when you have a control over your parent scripts, it would be much easier and practical solution. So let me demonstrate that real quick. So this is a second parent, so I can say 2, for example. I can do the same here just with 1. And if we go here, so instead of checking our parent that we got on this line, we can actually just check for the positional argument. In this case, we have only 1. So we will check if the argument that we were given contains 1 or not. And if it does, it will print 1 and 2. And if it doesn't, it will print 3 and 4. So this was just to show that this is not the only solution how to get around this problem. I already came across the case where providing an indication about the parent wasn't an option. So I think in situations like that, this could be very handy and useful. Okay, so that's basically it for this video. I hope that you learned something new and you can apply it in some of your future bash scripting. If you find this format of video interesting, stay tuned, and I will see you in the next one. Peace.